In this video, I will be discussing reduction of multiple subsystems. Individual subsystems are represented by a block with an input, output, and transfer function. More complicated systems are represented by the interconnection of many subsystems. Since the response of a single transfer function can be calculated, we can also represent multiple subsystems as a single transfer function and apply analytical techniques to obtain transient response information about the entire system. Block diagrams are used for frequency domain analysis and design. There are three common topologies for interconnecting subsystems, which are the cascaded form, parallel form, and feedback form. For each form, a single transfer function representation can be derived. In a cascaded or series-connected system, each signal is derived by the product of the input multiplied by the transfer function. For the cascaded subsystem, the output of system 1 is the product of the input signal Rs multiplied by the transfer function G1 of S of system 1. This output serves as the input to the second system. The input to the second system is multiplied by the transfer function G2 of S to obtain the output of the cascaded connected system. The equivalent transfer function of the cascade subsystem is the product of the subsystem's transfer functions. The second topology for interconnecting subsystems is the parallel form. Parallel subsystems have a common input and output formed by the algebraic sum of the outputs from all of the subsystems. We can see that the output of each subsystem is equal to the input Rs multiplied by the transfer function of each respective subsystem. The output of each subsystem is then summed or subtracted via an actuator depending on the sign at the actuator to produce the equivalent output of the parallel connected system. The equivalent transfer function of the parallel subsystem is the algebraic sum of the subsystem's transfer functions. The third topology is the feedback form. Feedback systems form the basis for our study of control systems engineering. Feedback systems can be positive or negative depending on the sign at the actuator. The transfer function of the subsystem can be derived from its input to output to obtain the equivalent or closed-loop transfer function GE of S. The product GS, HS is called the open-loop transfer function or the loop gain. To learn more about closed-loop systems, please see my video entitled Control Systems, where I explain the difference between open-loop and closed-loop systems. Let's look at an example of how to reduce multiple subsystems to a single system using the MATLAB Control Systems toolbox. In this example, we want to find the equivalent system transfer function for the given subsystems G1 of S and G2 of S in the cascaded, parallel, and feedback form. We first create the transfer functions for G1 of S and G2 of S. Next, to create the cascaded connected system, we use the command series, and this creates a cascaded connection. For a parallel connected system, we use the command parallel, and this creates a parallel connected system. For a feedback system, we actually use the series equivalent transfer function, and we have another transfer function that's used as a feedback. And then we use the feedback command to create a feedback system. Another way of doing this is actually multiplying the products of the G1 transfer function and G2 transfer function to create a cascaded connection. If we want to create a parallel connection, we can add the transfer functions or subtract the transfer functions. If we want to create a feedback connection using the algebraic operations, we actually use the closed-loop transfer function, and in this case, our G would actually be the series equivalent transfer function. If there are common terms in the numerator and denominator and we want to remove those terms, then we can use the min-real command to remove those terms. In conclusion, we discussed how to represent multiple subsystems as a single transfer function in cascade, parallel, or feedback form. We also used MATLAB to illustrate examples for reducing multiple subsystems for each topology. If you've enjoyed this video, please like, share, comment, and subscribe, and I'll see you in the next video.